from all over the globe to APQP webinar sponsored by ASQ Automotive Division. Next slide, please. Here's the agenda we're going to go through today. First, we'll cover the housekeeping items, give you a short information about the ASQ Automotive Division, and then we'll have the webinar topic, which is the Advanced Product Quality Planning, APQP, and at the end, the webinar presenter will be able to answer your questions. So next slide, please. From the housekeeping standpoint, right now, everyone is muted. The session will last about 90 minutes, and the slides, after a day or so, you will be able to download from the ASQ Automotive website, which is listed there. Participate through the chat and questions. While the presentation is going through, you can still, on your right-hand panel, you'll be able to chat and ask questions. And Walt Aldeck, who is going to be, as I'm saying, this program, he will moderate the question and answer session at the end of this presentation. So give you a little bit background about the ASQ. It's American Society for Quality. It's the world's leading professional association with quality professionals. We have membership all over the world. The ASQ Automotive Division is one of the divisions within the American Society for Quality, and it is a recognized global network of automotive quality professionals. And what we really want to do is to help the individuals and the organization to achieve the personal and organizational excellence. I would really highly recommend that all of you become ASQ Automotive Division member. If you are already an ASQ member, for only $10 additional, you can become an ASQ Automotive Division member, and there are lots of benefits of becoming the member of the American Society of Quality Automotive Division. Here are the key objectives as we move forward for the Automotive Division in 2012. Number one is to increase the member value. We have been doing a lot of different webinars, and I hope your continued participation into this webinars. We also have symposium, and in 2012 we are going to have a symposium in Metro Detroit area, and then also we are going to have a symposium in southern United States. We are also developing core tools competency, and what this means is for any quality professional working in the automotive industry, there are some core competencies which are going to be required and to be successful, and those are the PPAP, the APQP, FEMA, SPC, and MSA. And at the end of 2011 and the beginning of 2012, we had one webinar for each of these topics. Today is the final topic, which is the APQP, is what we'll be covering today. We are also reaching out globally. We don't want to be Detroit-centric, so any of you who are outside the United States and you would like to be more active with ASQ Automotive Division, we highly encourage you. We are also trying to be outside of the Detroit area, so if you are OEM in southern US or anywhere else, or if you're a supplier, we'd like to get you involved. We also want to make sure that the next generation of quality professionals is also being developed in your universities and other places. So if you are in any colleges or universities, we would like to collaborate with you to spread the word about the quality. So collaborate with the other professional societies. We will highly also encourage you with dealing with other professional societies like Society for Manufacturing Engineers or any of the other ones. Next slide. So I mentioned in the previous slide about the 5 core quality tools. These are the 5 which are listed here in their full form and the short form. And American Society for Quality Automotive Division itself is encouraging organizations to have training classes on site, and we can provide you with certified instructors and is going to be one of the instructors who is an excellent. Mark Morris is an excellent instructor with nationally and internationally known. So we have great instructors who can teach these classes. Next slide. So how do you get in contact with, if you want to get more involved with the ASQ Automotive Division? We have many different ways to do that. You can contact me, Kush, who I'm the chair for the Automotive Division. I have my email address listed there. You can also go on our website. We have also the presentation from previous webinars which we have done. We are also very active with the LinkedIn group, ASQ Automotive Division. If you can go on that group, join the group, and then you can ask questions and start discussions there. And then we also have a Twitter account, so Walt gets very much engaged with that particular one. So there are many different ways. Whatever works for you, please get involved. Call for speakers and volunteers. We are always seeking new speakers and other ones. So if you are expert in specific topic, please contact us and we can review your content and see whether it's going to be appropriate for our next webinar. We also are looking for volunteers. We are all volunteers. Walt and myself are volunteers, and we need more volunteers to help us out. Their contact information is right there. So let's get started with the webinar. Let me introduce Mark Morris, who is going to be the webinar speaker for today. He has also done the remainder of the 4 other webinars of the core competencies. He has more than 30 years of experience with the machinist. He's not just a theoretical teacher. He has practiced it for what he's teaching. He's expert in dimensional issues, the reliability, maintainability, many different quality systems. He's certified quality engineer, reliability engineer, and certified quality auditor. He is also very much involved with geometric dimensioning and tolerancing. He's a past chair of the Ann Arbor section of ASQ, and currently he is an ASQ education chair for Ann Arbor section. So let me welcome Mark Morris.
Thank you. So we'll get my screen up in just a moment here. Good evening and welcome to the 5th and final of these sessions on the 5 core automotive tools. We started back in the middle of November and with production part approval process, and we're going to circle back to that as we talk about the advanced product quality planning process and the emphasis on control plans that's given in APQP 2nd edition. So here we go. I was trying to figure out how I ought to start this final, 5th and final session with you. Some of you might be hearing me for the first time, and others of you may have connected all 5 times. I picked up this quote down at the archives of the Henry Ford Museum. I was studying the people who went to the Henry Ford Trade School. That was the topic that I was after, because so many of my employers, the company owners that I had worked with, especially early in my career, the mid-70s, those people were graduates of the Henry Ford Trade School. And I was trying to figure out what exactly made them different and what made that school different than other trade schools in other organizations. And I ran across this quote that left the 5 fundamental principles, and I think they tie very nicely to advanced product quality planning. So here they are. Cleanliness and safety come first, then accuracy. Slow accuracy is no longer valuable So speed is the fourth ideal, and fifth is originality, the ability to develop better methods and better work. Well, isn't that what quality planning is all about? The ability to develop better methods and better work? These seeds were planted back in the 1940s at the Henry Ford Trade School. Then I sometimes use this quote. I was in the room when Hank Nickel made this statement. He was looking, this was at the Wixom Assembly Plant. He at the time was the Executive Vice President for North American Operations at Ford, and he was doing a quarterly quality review with many of the suppliers. And this was a Ford plant. They were producing the Lincoln, and as I recall, it was a Mark 8, the steering wheel. And the steering wheel had an airbag, but you could see the seam where the airbag would break through just by looking at it, and that wasn't part of the design. So we asked the supplier, not what's wrong with you, it's what's wrong with your quality system. What was it in your quality system that allowed you to ship us this junk? And I was just so thankful that I wasn't the supplier who had to respond for that at that particular occasion, but there were probably other occasions where I could have. The thought here is, how do we avoid situations like this? And the answer is held in the content of this course, Advanced Product Quality Planning. So the agenda for this course, and again, like the other webinars, I can't possibly go through an entire 8-hour session. Actually, we're working this session so that it can be offered as either an 8-hour session or an in-depth 16-hour session, going into considerably more detail, but the one-day presentation is the initial target that we're working on. And it's presented in the 5 chapters that are given. First, we talk about working within a quality system in your organization. Then we talk about the fundamentals of quality planning. And then we move to the AIAG model for quality planning. And then we move to control plans and bring things to closure. Well, I'm going to follow the same format, but I'm going to go lightly and not cover all of the materials because you just can't fit 8 hours of material into 1 hour. So that's the plan for this evening, to give you a flavor of what this course includes, maybe what it doesn't include. One other topic before I jump into working within a quality system. The last 2 sessions that I did, I was asked at the end of the session if I could provide references when I talk about people or quotations and whatnot, or books that I've used to help build these courses. And I've told you that I will be providing those references. They're all going to be presented in a single Word document. I just haven't had time to get them, but they will be broken into each of the 5 categories as far as references, and who knows, maybe you can add your own references to that list. We'll see how that goes with the website. So anyway, working within a quality system. The goals for this course: we want people to have the ability to have meaningful conversations. That requires fundamental understanding of the language that we use when we're talking about things related to APQP, and that's a major focus of this course. We want to use those APQP strategies to determine where we're going to assess special characteristics. That typically filters right into a control plan, and then use APQP as a means to achieve robust, capable processes for those special characteristics. Those are the goals of the course. So now, working within a quality system. A system that produces consistent product has to in today's environment reside within a quality system? Well, you probably remember the 3 subticks under the first bullet, the ISO philosophy. To say what you do, to do what you say, to be able to prove it. I remember sitting in a training class, and I was rather shocked when I was told that while these 3 points are necessary, they are not sufficient. That in addition to those 3 points, you have to meet all of the requirements in the quality system standard that you're planning to be registered to. And your application has to be effective. You can find those words in the quality system standard, and then if you were to take that standard and say highlight, every time you see the word shall or the word will or must or should, shall, will, must, or should, those are requirements of the quality system standard that you have to address. And then you have to address them so that they are effective. Well, here's a graphical representation to this. In my own career path, what I've found is that, well, there were 2 stints in my career where I played the role of a technical writer, writing about how machinery ran or what an operator had to do. And that helped me immensely when I started to write about quality system requirements. Addressing every shall, will, must, and should in the standard will allow you to get through the first decision box. It's not just saying what you do, but it's making sure that the things that you say you do are consistent with the requirements in the standard. If you don't do that, what will happen is you will, when you have a surveillance audit, you'll have 3, 4, 5 nonconformities again and again and again, and they'll be different and they'll be unpredictable. Well, if you have that situation and you went back and looked at your quality system documentation, you'd find that you haven't addressed all those shalls or those wills or musts or shoulds. So that's that first block there. Doing what you say is just complying with the procedures. Having evidence is what allows us to succeed and increase profitability. Now, it seems to me that there's only 2 things that a quality system can do if it's going to pay for itself. The first is to open new markets, to increase marketability. I have a client who has an ISO-based quality system, but they wanted to get into the aircraft industry. So they saw the aircraft's quality system standard as the method to break into that new market. But related to advanced product quality planning, we have to be able to reduce the frequency of errors. If we don't reduce the frequency of errors, if we don't figure out by quality planning how to do things right the first time, the quality system will never pay for itself. It'll be a burden on your company. And of course, we don't want that. The other thing a quality system does is it gives you the vehicle to fix communications, to document who is going to do what and when they're going to do it in your procedures, and to procedurally define those things that are important to communicate throughout the life of the project. That's exactly what APQP is about. So here we have, whether you have an ISO TS 16949 or an ISO 9001 quality system that you're working to, This is the basic model. Management responsibility and resource management, product realization, measurement, analysis, and improvement. Those 4 major steps. And then there's some general requirements that talk about control of documents, control of records. When we look at the expectations for advanced product quality planning, they're found in the product realization phase. That's where we find the requirements for quality planning. And we have to have resources and that's part of management's responsibility. And then we have to manage those resources to bring the product to market, and we have to have continual improvement. That's the base structure of this quality system, and APQP is a subset of product realization. Now, last session, on 2 sessions ago on SPC, I showed this graphic. It's the Juran Trilogy, and I believe that your next webinar is by the current president of the Juran Institute, so he'll likely be talking to this. What we see in the Juran Trilogy are 3 different phases. We have the quality control phase when we try to stay between limits, try to maintain the status quo, if you will. We have a quality improvement area where we're actually changing the process to a new zone of quality. And we have a quality planning process that make up this trilogy. The quality planning process is going to determine how effectively we bring a product to market. That's what it's all about, and it fits within your quality system. Now, on the very first of my webinars, the one on production part approval process, we talked about the quality system documentation requirements to get approval to ship product, production part approval process. And there's 18 different file folders, if you will, in this document. And I usually start my discussion with the part submission warrant. Because if we don't achieve this document, this credibility that we're ready to actually produce product that's conforming with the authority to ship it on our customer's demand. That's what this part submission warrant is all about. These other pieces, the design record, the authorized engineering changes, the design FMEA, the process FMEA, your flow diagrams, your control plans, these are all functions of quality planning, of the Advanced Product Quality Planning Process, APQP. They are all part of the APQP process, but they are not all of the APQP process. Did you hear that? These 17 items, and the 18th if we include the part submission warrant, make up, they are part of the APQP process, but they are not all of the APQP process. There are other components that aren't related to these 18 topics that also fit into the APQP process. Otherwise, PPAP and APQP could just be interchangeable. And unfortunately, they're not. So these requirements are intended to be achieved during a significant production run, unless otherwise specified, a minimum of 100 parts taken out of 300 parts that we actually measure, and they are taken at the production site, running at the specified production rates, using the production tooling, the production gauging, materials, processes, and production operators. And if we have multiple process streams, then we need to test product from each of those product streams. And the goal of this is to achieve a PPAP approved process. So we could think of the APQP process, or the goal of the APQP process is to get PPAP approval, to get approval to ship product to our customer at their demand levels. Now, we can't do this in a vacuum. We can't do it one individual, so we bring together cross-functional teams, and we talked about that in the class. Generally smaller teams, and bring in experts as needed, and we talked about this also in the FMEA class, the need for cross-functional teams. And some considerations for meetings. None of these are new. They're taken from valid resources, and we look at common team problems, the overbearing participants, the lack of understanding or of common understanding, a general rush that we want to get to work, we want to get to the accomplishments. And people sometimes come in with hidden agendas, or they just go through the motions. We want to get the right people on the teams, clear expectations, assign responsibility for the actions, and manage them to a timeline. I include here the rules for brainstorming because brainstorming make up a part of the APQP process. So, in the webinar on FMEA, I presented to you a rational structure for quality planning and told you this was actually developed out of some threshold pain that I was going through and my customers were going through and my suppliers were going through. This is prior to the publication of the first AIAG documents, when Ford had their own documents for FMEA, and Chrysler and GM and other companies outside of the automobile industry. Well, they all talked about doing a design FMEA and then doing a process FMEA. But in the world that I was working in, what I saw was that for us, it made sense to do a process FMEA and then a design FMEA. But we were focusing on a different level of design, on the machinery design. And this model seemed to help a number of people understand what we were trying to accomplish with quality planning. Now, I got several comments after the FMEA webinar about the inclusion of the tooling, that was an interesting aspect that some people hadn't considered. But if you look in the appendices of the APQP manual, what you'll find is that they specifically address, they have a check sheet, for example, that deals specifically with tooling and machinery and measurement equipment. And we have another checklist that deals specifically with the process FMEA and one that deals with the design FMEA. So these are included in the APQP manual by means of a series of checklists that are found in Appendix A. And from my personal opinion, I see them as some of the strengths of the APQP manual and of this course. Well, then we can look at the motivation of each of these phases, looking at the product and the product design. The product design has to meet requirements that would likely appeal to a car buyer if we're in the automobile industry. So we look at flushness and margin of closures, and we look at the Class A surfaces, whether they're outside on the body of the vehicle or inside in the instrument cluster or something like that. They have specific requirements, product design requirements, and they impact the customer satisfaction. Now, the processes have to be able to meet the product requirements. They have to take the incoming material and turn it into this product that meets the customer requirements. What motivates us here is the ability to reduce our life cycle cost, the ability to take into consideration which plant the tools and the product, the tools are going to reside in and the product is going to be built in. And that takes us down to the tool design and the machinery FMEA, or we could have internal process FMEAs as well. Well, the natural fallout from the APQP process is a control plan. And here we identify for the customer's plant, the plant that's actually going to be building the product, they have a phase 1 control plan when they're in prototype development, and then a phase 2 when they're in pre-production, and phase 3 when they're in full production. We'll want to consider these 3 phases when we look at the AIAG model for advanced product quality planning. This looks at a rational structure and applies to project-specific control plans. So if I had to make, for example, a framing station, that framing station has to have process requirements, it has to have design requirements, and then there have to be some things that control how it's assembled, how it's tested, how it's put into production. So those would be a different aspect on control plans. Fundamentals of quality planning, our second chapter. We start with these PPAP documentation requirements. They are what we should first think of when we talk about APQP. We want our quality planning process to make sure that we understand what the customer's requirements are. And that's the intent of the design record, to ensure that we understand what it is that the customer really wants. And if there's a need for authorized changes, then we have a place for those and for engineering approval. And design FMEA and so on for the other 18 categories. These are a function of quality planning, but they are not the limit to quality planning. There are other things involved. I already showed you these. So the fundamentals of quality planning in this first chapter of the APQP second edition, these are the topics that they talk about as an introduction to APQP. How to organize the team, how to define the scope, how to ensure and set up for team-to-team communications, whether those are internal teams to your organization or whether they reach out to your customers or to your suppliers. What training is required? Customer and organization involvement. Simultaneous engineering, control plans. These topics are all introduced in this first chapter, and then they're woven together in later chapters. The product quality timing plan, when are we going to do all of these quality planning activities that we've identified? Then we look, if we're looking practical, about containment strategies. You know, you may have heard me ask this question in an earlier webinar, but it's an interesting question, I think. Have you ever had the opportunity to shut down an assembly plant? I have, once. It was a learning experience. It's interesting. It's an exciting event. Exciting in the worst possible meaning of that event? You get a lot of attention. Well, we need containment strategies. We need to consider, as we're doing our quality planning activity, if we're looking at the fundamentals of quality planning, we need to consider what are the costs of defects and what are the risks of seeing those defects. And how can we develop strategies so that we know our testing strategy, our control plan strategy, will identify problems before we ship them, and ideally before they're even made. You know, the transition from mistake proofing to error proofing. Protecting on-time delivery. Eliminating the cost of stopping production. Those can be real serious costs, or recall campaigns. And we even talk about the benefits of traceability, whether serialization makes sense for a given product, whether it's required or not by your customer. Does it make sense for your business? Practical issues related to quality planning. What's the cost of inspection? And what's the risk if you don't inspect? And then how often should we inspect? How many parts? When does 100% inspection make sense? What do we do when we have destructive tests? You know, it used to be a joke in the welding community. How do you never ship a bad weld? 100% destructive testing. That'll do the job. Think about it. It's I don't know if the humor comes out over the webinar experience or not, but it's intended to. Here's the AIAG model for quality planning. What we have are bars that come across like so, that traverse horizontally, that make up phases. So we have the planning phase, we have the product design and development phase in yellow, we have the process design and development phase in red, we have the product and process validation phase here in blue, and in gray we're into production. And then this blue bar along the bottom has the feedback assessment and corrective action, kind of a living set of lessons learned. And then if we apply timing across these bars that are identified at the top, the concept initiation approval, the program approval, prototype, pilot, production, these kind of tell us where we are in a very generic sense. So it sets up a guide, a model for quality planning. Now the way that the APQP second edition manual is set up is they give a chapter to the things that go on during this planning phase, and then they give a chapter to the things that go on in the product design and development phase, and then with the process design and development and so on. Those are the structure of their 6 chapters, or their first 6 chapters. And what they do is they say, for the planning phase, for example, you have input documents. So these would be a list of the input documents, and they provide a paragraph description about each. We'll provide one slide on each, just walking through what these documents mean to people who might not be familiar with them in a training session. Then because of the actions taken during this planning phase, we develop some output documents. The design goals, the reliability and quality goals, the preliminary bill of materials, and you can read through them, a preliminary process flow chart, special characteristics, product assurance plan, management support. Well, what happens? That's in this planning phase. Then we move to the next phase. Well, the output documents from that planning phase become the input documents to the product design and development phase. So if we look at this yellow bar in a bit more detail, what we'll find is these outputs from the planning phase are identical to the the inputs to the product design and development phase were the exact outputs of the planning phase. And then through the process of product design and development, we will develop the design outputs, which will include the FMEA, design for manufacturing and assembly, design verification, design reviews, and so on. Your drawings, your specifications, your material specs. And they'll also include some specific automotive, APQP outputs. These support specifically the quality planning process. Do you see the difference? If I go back, these are the design outputs out of product design and development. These are the APQP outputs from product design and development. So there's two sets of outputs there. The ones that carry forward are the design outputs, because we take the design outputs and we take them into process design and development. So we end up with this set of input documents. And as we work through process design and development, we develop the packaging standards and specs. We develop the product and process quality systems review, flow charts, floor plan. And some of these, for example, our flow charts, are going to be part of our PPAP documentation, but there's not a requirement for our floor plan layout to be part of that PPAP documentation. But it's still important that we do it. I've seen tools that were placed so that they run right in the middle of a column. And it just doesn't work very well. Or where they've had to build an addition to the factory because somebody misplaced a tool in a manufacturing process in the floor plan layout. Characteristics matrix, the process FMEA, and you can read on through. These are the output documents from this phase, the process design and development phase. And we go through each of these so that we have a common understanding. And for some of them, we actually have some activities involved to help the learning process go on. So that's our product. Our process design and development. Those outputs will be inputs to the product and process validation process. Well, this validation process is doing the things that we need to do to get our PPAP, but there's some other things going on too. Validation testing, packaging evaluation. We have a production control plan here. If we looked back, we have a pre-launch control plan or a pre-production control plan. Now, these are intended as a generic approach to advanced product quality planning. They're intended to cover many of the cases that we would see and to get us thinking. But if there are documents that you deal with in your company, either input documents or output documents to a given process phase, by all means add those. Have this make sense for your organization. And if there's something that doesn't make sense to your organization and it's not required by the PPAP process, then you may be able to eliminate those. So now we're looking at being in production and providing feedback. We have our input documents going into production. And we have our output documents once we're in production in order to continually improve, to reduce variation, to reduce weight, to reduce time, to improve profitability, and on and on and on. Practical issues with quality planning? We looked at this. My apologies. A strategy for actionable data. No inspection without recording. No recording without analysis, and no analysis without action. The words that Dr. Deming spoke, I was in the audience, 1990. And the reason that these words are here, the strategy for actionable data, is this is my transition slide. This is my lead-in slide to developing quality plans, or control plans, to developing control plans. So that's our next chapter, control plans. This I included because, well, not all of my customers live in an automobile world or an automotive environment. I found this example of a control plan in Quality Planning and Analysis by Juran and Juran, and it's the simplest example that I've run across of a control plan. There's just what we're looking at, what are we doing, how many a day. It's compare this with the AIAG approach. There's a bit more on here, wouldn't you say? The first thing we have to do is we have to identify what type of a control plan we're going to be doing. Is it a prototype? Is it pre-launch? Or is it in production? And we've got a place to identify what page number of how many pages there are, the control plan number, and you can see these are pretty straightforward. What's in the upper portion, the upper 4 rows, is what I call card catalog information. So that if we're doing a similar product in the future, we can pull past control plans and see what people had done as part of our library of lessons learned. These, starting from the 5th column on, are our headings for the columns. So the first column is going to contain the part and the process number, the process name and the operation description, the machine, the devices that are used to make this product, the characteristics that we track. We number these 1, 2, 3, 4, 5, or 10, 20, 30, 40, as you prefer. The characteristics are either looking at product characteristics or process characteristics. A product characteristic is something that we're actually going to measure on the product. The process characteristic is something that we're going to control within the process to assure that the product characteristic is going to be conforming. And sometimes people get challenged by the terminology. If you were to take an example of spot welding, a product characteristic might be the nugget size of a spot weld. The process characteristic might be the cycle in hertz, how many or how long the heat is being applied during the welding process. Or another process requirement in that same application might be, if you have a pneumatic weld gun, the air pressure of the system. Because sometimes other components in a set of tooling will want to draw on that air supply, and we may not have sufficient air pressure to give us the weld force we need to produce the nugget that we're after as a product requirement. If we have special characteristics that have been identified either during the designing process or the development of the manufacturing process. We can identify them in this column. We can put the specification and tolerances here. So if it's a profile of a surface tolerance and it's 0.2 of a millimeter, then that's what we put down. Evaluation or measurement technique, how are we going to assess this? How often are we going to assess it? What's going to be our sample size? What method are we going to use to analyze the data? And if things go badly, how are we going to react? That's the essence of a control plan. And then AIAG identified some dominant processes. Some of the problems that we see that are equipment dominant, they're affected by the setup of the process, or by the machine selection, or by a fixture or a pallet combination, or by tooling that plays the dominant role in the equipment. But people can also be dominant in some processes. If you go back to welding, spout welding, you might have an individual who has to move around a weld gun that's hoisted on some type of a counterbalance to give them the ability, and then maybe have a Bakelite guide or something that doesn't conduct electricity that will guide the spout weld gun tips to where you want the weld to be. But the operator in that case, you know, we'd want those weld tips to approach the sheet metal at a 90-degree angle. But the angle of approach is an operator-dominant process. We have some material that can make the process material dominant, and some methods. And the environment can certainly influence or dominate a process. These are described in the AIAG APQP 2nd edition manual. Then we move to reaction plans. The explicit strategy, what are we going to do? You know, and what I see out in the real world, in the plants will have these control plans, but some plants choose to put the information that's in the control plan about what the person is supposed to do into a work instruction for that particular station, and take it out of the format of the control plan for simplicity's sake, to make it easier for people to understand, to follow, and to follow the instructions. 3 specific questions that are related to reaction plans. Are the reactions planned, and are they documented? A lot of time we won't put them in the control plan. What we'll do is we'll reference another document, the reaction plan for this situation, reaction plan number 001, 002, whatever. Are appropriate assignments made to manufacturing, to engineering, to other activities in the reaction plans? And will both suspect and known non-conforming product be quarantined until appropriate action has been taken? So reaction plans give us different specific solutions for given situations. For example, instability, the lack of process stability. Instability when special causes exist. Incapability when we're not able to make parts within the specified tolerances. So they have appendices that run A through G. This is the first of the appendices, Appendix A, and it's made up of these checklists. these checklists, they have one for the design FMEA, another checklist, I think it's 32 questions long, something like that, a pretty in-depth set of questions on design information. Have you asked the right questions? And then if you have applications of new equipment, new tooling, new test equipment, a checklist for those. Product and process quality, the floor plan, these checklists are ways to assess, are we doing these really important quality planning activities, and are we doing them well? The control plans, I broke their checklist into a set of 3 slides to make them big enough for you to read. The first question, was the control plan methodology referenced in Section 6, that's of the AIAG 2nd edition manual, were those methods, was that method used in preparing the control plan? Have all known customer concerns been identified? Are all special product and process characteristics included in the control plan? You know, this is the answers to these questions allow us to assess whether we've done an adequate job in planning for quality. So were the system FMEA, the design FMEA, the process FMEA used to prepare the control plan? Are material specifications requiring inspection identified on the control plan? Does the control plan address incoming product through processing, through assembly, including packaging? So there's these questions that we ought to be asking as part of the advanced product quality planning process. So what we have are a series of inputs and outputs to each of the phases, and then we have a series of checklists that make up Appendix A that kind of guide us to whether we've done an adequate job or not. Appendix B gives a very short presentation of the following analytic techniques. And then the rest of the appendices, there's reference materials, a team feasibility commitment form, a strategy for APQP summary and approvals, the glossary and index. Those make up the appendices. So as I bring this webinar to a close, what we have is an APQP model for quality planning. And it's made up of these phases, the planning phase, the product design and development, process design development, product and process validation, and then production. And then we also have these 18 components that make up the PPAP. Well, one of the things that I've done very successfully in teaching this material is to create a laminated sheet that has the AIAG model for APQP at the top of the sheet and the 18 components of PPAP at the bottom of the sheet. So the sheet is probably 11 by 17 or so, and these are reasonable size blocks. Well, I hand out to the students packages of modeling clay. When's the last time you got to play with modeling clay? And what the students have to do, they're broken into teams to do this little exercise, and what they'll do is they'll make this two-dimensional model a three-dimensional model. The modeling clay comes in 4 colors, so they'll find the green clay and they'll make a bar out of modeling clay for the planning phase, and then out of yellow that has that slope, and they turn this two-dimensional model into a three-dimensional model, and at the bottom of the page And they've gotten really creative using credit cards to cut the clay and stuff like that, so they can put a piece of clay on each of these 18 elements and a piece of clay the size of the box on each of these APQP phases. And then I give them spools of wire and wire cutters. So far there's only been one Band-Aid required. And what they'll do is they'll connect the dots. They'll connect the concepts. And they have the most wonderful conversations as they're doing this. And they come to a clearer understanding of how APQP works in their organization. And sometimes people are looking. I had one individual who was mostly from a testing environment, focused on one part of this model, and other people who were looking at more the production process, the process development phase, develop a whole different view of these wires that connect these dots, because that's how they see it. And the communication among the participants is just absolutely wonderful. So we have this agenda, these 5 chapters, and we have these course goals to give people the ability to have meaningful conversations on the subject matter of APQP, to use these strategies to determine special characteristics, communicate special characteristics, and develop robust, capable processes for those special characteristics. So that is the end of my presentation. We have time for questions and answers.
Okay, Mark, while everybody go ahead and type your question into the the question box on your the floating bar to the right, and we'll give a couple seconds for them to queue up. And in the meantime, I'd like to remind everybody of our next webinar. As Mark said, it's we're honored to have Joseph Defoe, the president and CEO of Juran, going to give a series of webinars for us. And the first one is called the Juran Trilogy, and it's February 29th, same time, Wednesday, 7 p.m. He's also going to do 3 more, and we don't have the times on them yet, but the second one he's going to do for us is how do I keep my job during difficult times? The third one is going to be Lean Six Sigma. Does it improve the top and bottom line in most organizations? And the fourth and final one from Joe is going to be it's still the customer first. So for the first one, the Juran Trilogy on February 29th is already up there, so please go to our website and register for that. Okay, Mark, you ready for some questions?
Sure.
Do you recommend to use control plans to control special characteristics when the process capability is above 1.67?
Okay. What I think is appropriate is that during the PPAP phase, when we're first demonstrating compliance, that yes, I think they ought to be on that control plan. And if we can demonstrate during this pre-launch control plan that we have a very robust and capable process, then I don't have a problem moving to some other strategy than is required at the pre-launch phase where we need more data. I would certainly consider looking at a less data-intensive situation. I like the idea of combining pre-control, spreading the tolerance zone into 4 equal areas, the middle 2 areas green, the outer 2 areas yellow, and to develop a hard gauge strategy that uses the principle of pre-control if you have enough production to warrant the cost of the gauges to do that. That way you get an early warning signal. You'd be measuring less parts, but you can only do that for robust, capable processes. Processes, for example, with CPKs over 1.67. So you need to demonstrate compliance for your PPAP. After that, you can negotiate reduced requirements for those. And I suppose it would depend on what the characteristic is. You know, if it's a motor vehicle safety standard, you may not be able to take that advice. So those are my thoughts.
Okay, we got a ton of questions coming in, so we've got a lot of great questions. Next one. How come you don't include sourcing as one of the PPAP requirements, the 18 elements?
Sourcing. It's not included in the PPAP 4th edition, unless I'm mistaken.
Fair enough. Would you please explain the difference between special characteristics and critical characteristics?
Critical characteristics is one category of special characteristic. You can have, and you can define these within your own company. You can have a critical characteristic. You can have major characteristics. You can have minor characteristics, all of which are special characteristics, but they would be in descending negative impact.
Okay. And how do we document an interim PPAP approval via OEM deviation process?
I am so far away from PPAP right now. If you could email me that question, I've just had my mind wrapped around APQP, and that one, if you send it to me via email, I'd be happy to do my best to answer.
Okay, and I'll send all these questions to you, Mark. They part of a go-to meeting. It kind of sums them all up. Here's another one on PPAP. What's the industry recommendation sample size for an initial product run PPAP?
The default is 300 pieces.
Okay. How could I get a copy of this presentation? That'll be on our website, asq-auto.org, and that'll be on there tomorrow morning sometime, say before lunch. You had R and M on one slide. They don't.
That stands for reliability and maintainability.
Okay.
Those are measures of equipment performance.
Do you have a preferred OEM APQP process? Chrysler's PSO, Ford's phase PPAP, etc.? I guess, can you comment about them?
They exist. It's working with your suppliers to make sure that you understand the requirements, or that they understand the requirements, and that they're able to meet those requirements. If you're on the OEM side, on the receiving side, if you're on the delivering side, it's making sure that you understand your customer's requirements and can achieve those. So the various requirements that have to be documented for a PPAP are one thing, but those aren't all of the things that have to do. The PPAP documentation does very little, maybe in testing, element 10, on assessing the performance of the thing, as in reliability goals being met and things like that.
Quite a few questions on about where we get the slides, and once again, asq-auto.org, and I'll have them up there sometime tomorrow.
Sometime next week, I will send you, Walt, a slide or a file of references that I've used to create these 5 courses, and you can put that up with them.
Okay, great. The ISO TS 16949 Annex A requires to include corrective action into the control plan. Besides reaction plan, What does it mean?
Can you repeat the question, please?
Yeah, part of ISO TS 16949, Annex A, requires to include corrective action into the control plan. Really, what does that mean?
Okay, corrective action is really about finding the root cause and taking action on the root cause. So when we have non-conforming product coming out of a process, that non-conforming process has to be quarantined. It has to be taken out of the system.
Okay.
I had some other thoughts, but
okay. Let's move on. In QM, is a QM plan different from APQP?
I've not heard of the QM plan by that those initials. What does QM stand for?
Yeah, I don't know. So when you ask the questions, I guess, folks, try to be as specific as possible. How do we calculate the accumulated occurrence numbers on one FEMA to predict planned quality performance? I don't know if there's enough information in there for you.
I'd be happy to try and tackle that one if you emailed it to me. I'm not understanding the question very well. My apologies.
Oh, the QM is a quality management plan. Some of these questions in here are similar to the other ones. I think they're going to trip us up. I know in the quality engineering that we calculate sampling plan based on CPK performance. Is it acceptable in the automotive standard application?
I don't believe that's explicitly specified.
A couple questions asking for your contact information, Mark. So if you can...
Oh, let me... It's Mark at M&M Consulting, or our website is www.mnmconsulting.com.
Yeah, so please contact Mark. Any more questions? There's a couple questions about, are we recording the webinars? Technically, I am recording them. We've been having a little bit of problems with uploading them to the website and the bandwidth issues to do that. So we're wondering, how do we go forward with that? If we do go forward with that, we may limit that to only ASQ Automotive Division members. So hang tight on that one. We'll have all the slides available to everybody, but a little bit of technical difficulties with the recording, so we'll have to decide what we want to do with that. So if there's no other questions, I'd like to thank everybody for attending, and I'd like to thank you, Mark, for a series of 5 wonderful webinars. This was our 15th webinar, and we're over 1,000 people attending. So Mark, you're a big part of that, so I'd like to thank you. And I look forward to everybody joining us on our next webinar on February 29th, the Juran Trilogy. So please register on our website, and we'll talk to you next time. Thanks, and have a good night.
Thank you so much. Bye now.